Um, hey, hi. Yeah, so um, I wanted to talk about something I've been mulling over, and it's like, how do we, as we go towards evolving the protocol, what does that look like? Like, what can we do with move from root network based emission allocation towards market based? And the mental model I like to have for this is that as opposed to relying on 64 validators to determine what the subnets gets, tau holders get to express their preferences by voting with their capital. So the more people that stake to a particular subnet, it's like a market force. It expresses, the organism Bittensor's will for the thing to thrive. So that's what that does. So when we have that, you know, when we have that, we also have like, we've done a lot of thinking and we think, okay, what if, because not everyone might want to go to detail. Not everyone might, some people might be more comfortable here. So there is a form of detail that exists that people have multiple mechanisms. Now, what is a mechanism? You can look at it as a mechanism as an allocation tool. Like what rules does the government, what rules does does that sub protocol use to allocate emissions between different networks? So yeah, so that's that. So imagine a world where there's multiple mechanisms. You have the current root network running, you have S-Star running, and the design space is unlimited. So okay, what else can we do if we have different mechanisms? We know what detail is going to do. We have an idea of S-Star is going to do. Well, what more can we look to get out of this process? This is not sanctioned. It's really experimental, and there's no code been written. There's no plans been written. So yeah, let's go. Okay, so
There we go.
let's go back to 101 on human consensus and how it is the best decentralized subjective utility tool out there. But again, it's good at like, well, it's the lesser of all evils at measuring subjective utility. Everything out there is absolutely terrible. It has its flaws, but fundamentally, I think it might be overkill for things that do not require subjectivity. So I think, yeah, let's dream of a better model. Like, can we have, another mechanism? Can something else thrive where, it better assesses an objective good? Okay, so this is where we go to, okay, let's think of a model. We have subnets without validators. So like detail will sort out will replace the um, allocation to subnets, but not the allocation within it. So what does this look like a subnet without validators, and how would it fit into the current system? Yeah, apologies. This is a terrible diagram, but I didn't have that much time. So this is a kind of schema that we can imagine in that, okay, you have root network working somewhere, you have like the normal YC2 working, but for some subnets or for a different mechanism, all you have is no validators, just neurons producing the digital good. They submit it to an off-chain worker slash an oracle, and the subnet owner provides like a kind of a second factor authentication. This could be cryptographically signing it or be the person that physically issues challenges to the UIDs. But that being said, it's like, it's a more vested party that is submitted to Subtensor and Subtensor pays it out. So that's the very high level. I mean, it's mainly a thought experiment now, but it could become something because again, you know, a lot of the problems we face right now is because we're trying to do subjective utility. But for some goods, maybe so things like compute storage, maybe we can like possibly produce things that are even far better. Okay, so possible benefits. There is nothing like weight copying here because there's only one judge. Well, there's only one ground truth, so there's not multiple things. So we don't have validators, and more importantly, is that one problem I see with the current system is that it's hard to ask people to validate 1,000 networks and also ask them to be in charge of selling the digital, monetizing the digital good. I mean, I love what people like Coursera and Coursera and TaskStats are doing, but it's really, really hard for someone to be specialized in 46 different subnets and enough to buy that to collect their bandwidths and produce the good. So yeah, so I think this will solve it because again, no one will understand the protocol and no one is more vested than the subnet owner. He gets all the bandwidth and he or she is responsible for monetizing it. And yeah, profit. I think it opens up the space for not a perfect, but a more egalitarian system. Thanks. Does anyone have any questions? Let me see. Yes, we can do. Okay, hold on. Consider the subnet not having significant advantage. Oh yes, Namori, I agree. So ref, yes, so you say that the off-chain workers and subnet owners are just a singleton validator. Yes, but again, this is just high level. We can make things trusted. Like, proof of insurance can be interesting. We can actually punish or mitigate this thing at the protocol level. You understand? But there's also problems that, okay, the subnet owner running a minor validator. I don't have an answer for that at the moment, but it's definitely something to think about. And it's first of all, it's a problem in the current system. So this doesn't. I would argue that this neither exacerbates or ameliorates it. But again, it's probably something we should think about because again, one of the things that might help is offering like on-chain identities and working to make that civil resistance. But it doesn't come it doesn't complement the ethos of decentralization because a lot of things revolve around KYC and stuff like that. And I don't think it's things we want to introduce into the ecosystem. Who runs the Oracle? Um, Good question. So again, there's designs for decentralized oracles, there's designs for trustless oracles, but we will need to think about the mechanics because again, it's not like a DeFi or it's not like a price oracle, but it's an oracle of the events and a register. So we'll need to think of the design. This is exactly like modules which Commune AI has. Well, I haven't heard about Commune, but I'm sure they're doing pretty good work. What is cool? Well, thanks. I'll be answering questions in the chat, and if anyone wants to build this with me, ping me. Thanks, all.
Thank you, Samuel. Excellent. So, Ref, did you want to go ahead and get started on your topic?
Yeah, okay. Okay. So I'm going to talk about scaling Bittensor validation. This is the current list of subnets. Well, okay, almost current. It's a couple of weeks old. It's a list of subnet numbers and GPUs, and I indicated with numbers how many GPUs of which type which subnet needs. And there is a bunch of the subnets that need GPU. Some of them need expensive A100s, and not every validator is willing to provide an expensive server with a graphics card to run every subnet. If we would have today a new subnet that wouldn't have any weights, but it would require an 80 gig card, which costs thousands of dollars per month, it might have a problem with attracting validators. And if it doesn't have validators, it might have a problem attracting weights. And this is a problem because ambitious, innovative subnets might be a non-starter on Bittensor ecosystem. This is not what we want. Now, this is the plan. Hopefully, we can make it so that every validator needs to run a constant number of GPUs, regardless of whether they validate 20, 40, 60, or 100 subnets. Okay, so how are we going to do it? Let's talk about how subnets look like in terms of validation. It's a perspective. It's not a full picture, but I try to make a perspective that would, for someone who's not deeply involved in this stuff, is not a subnet owner, that people can understand. On the left side, we have a subtensor. This is basically like the representative of the blockchain. On the right side, we have the miners. There's like 200 of them, but on the slide, we've just put 4, and there is a validator in the middle. Now, the validator has a couple of components. One of them is network. On many subnets, the validator either requests or the miners do provide to the validator some kind of assets. It can be text prompts, it can be 3D models, it can be images. That entirely depends on the subnet. Yeah, so whether the validator goes to the miner and says, hey, please send this to me, or whether the miner goes to the validator and say, hey, what can I do for you? Kind of doesn't matter. It's almost the same thing. Then we have a preprocessor. So this is not the case in every subnet, but for example, we do have a subnet, I think it's number 17, which gets a 3D asset from the miner, then renders it and makes kind of screenshots of it from different angles. And those screenshots then get evaluated. Not actually the 3D model gets evaluated, because that's very hard. So they make photos of it and look at the photos. We have a GPU in many subnets, as you've seen on the previous slide. And then we have a scoring algorithm, which takes whatever the GPU says, which is like whether this particular image shows at this particular asset, let's say it's a car or a ball or whatever, whether this shows a ball or not. This is then interpreted into scoring, which like indicates what relative quality this miner has. No, what absolute quality this miner has. And then we have memory, and we store this scoring in memory, which eventually gets turned to weights. So the tests are executed frequently, and they are pre-processed, evaluated on the GPU, scored and committed to memory. And then every now and then, let's say 10, 20, 60 minutes, they are sent to subtensor. And now let's go through this process again. Files are being sent through the network to the validator, which pre-processes it, then evaluates it on the GPU, has those scorings that commits it to the memory, and eventually, sometime later, it goes from memory to the subtensor. And then eventually the chain rewards miners proportionally to their weights. Now, the network can be a problem. There are some subnets which already struggle with amount of assets. It's just like if you have a few megabytes of an asset, let's say 5 megabytes, then on a gigabit network, you can only get 200 of these per second. But if miners are rewarded by the amount of assets they can generate, they can overwhelm the validator with the assets that they're providing. And also the GPU can get on fire. There can be maybe not volume of data, but amount of prompts or images or something can be so high that the validator cannot possibly evaluate all of them fast enough on a single GPU that it has. Now, the plan is to use compute hoard for validation. So how would that work? The miners would send the assets to compute hoard, which would, I think it's not indicated on this image, but they would get pre-processed in compute hoard, and the scoring information would be sent to the validator. So the validator in this image does not have a GPU. This actually, technically speaking, it should probably, compute hoard should download the asset from the miner. But that's a technicality, who initiates the connection. And then the validator will have an execution agent, which may be on the separate machine, maybe on the same machine, and it will use that one in just a moment for cross-validation. It's a little thing that I will explain in a moment. But in the end, the weights are sent to memory. However, from memory to subtensor. However, sometimes the same data that got evaluated on compute hoard will also be evaluated on the trusted local execution agent. That is the hardware run by the same validator. So let's say it's 3%. So for 100 requests, randomly we select 3 of them and we run them locally. Because the validation will be deterministic, we will come to that in a second, the results of the execution on the local worker and on compute hoard should be exactly the same. If they are not the same, then the validator will realize that the compute hoard miner is cheating. Because the compute hoard miner may think, okay, I'm going to register on compute hoard subnet, and I'm going to do a good job, except when a validator asks me to evaluate an asset that my miner on a different subnet produced, I'm going to say that it's awesome. It's one of the best I have ever seen. And then you could think you will make more money on the cheating or on the evaluation than actually you will lose on running an inefficient compute hoard worker. But because the subnet validator will, from time to time, but frequently enough, run the cross-validation on trusted hardware, it will realize that it's cheated, and it will send the information to compute hoard. Now, compute hoard will get that information as a hint, but it will verify the claim. If a validator will say this is actually a proof here that someone is cheating on compute hoard, then compute hoard will run it again on trusted local hardware. And if it will realize that indeed this is a cryptographic signature proving that this miner on this input using this algorithm produced this output, and we execute it again, and we have a proof that this is a deterministic algorithm, and we got a different result, then it means that this one is cheating. So we eliminate such miner from the subnet. It will not be a very good business. You can cheat like a handful of requests before someone finds out that you're cheating, and then you're removed completely. This miner gets eliminated, and another miner on the same subnet takes its place. This can happen on multiple subnets. So we can have subnet X and subnet Y, and compute horde currently has like 2,000 GPUs that can be used for this, so a sizable amount should be enough. But then, this is a very animated slide. Those validators don't necessarily need to have a GPU per subnet. They can use one GPU to cross-validate multiple subnets because they send only like 3% of requests, or maybe 1% of requests, or however they configure it. Actually, they can initially just, when we will be testing this, we will be running 100% on the trusted hardware to make sure for a couple of weeks that it's running right before we start scaling it down. And this allows a validator to have one GPU per type per entire bit tensor rather than one GPU per subnet, as shown on this slide. Now, why can't we use one graphic card for everything? The determinism is kind of local to a graphics card type. Graphics cards are kind of over-optimized and they lose precision. So if you ask two GPUs to perform the same mathematical operation, if it's the same GPU running on the same firmware, it's going to give you the same result. However, if you ask a different GPU, it can give you a different answer. So in order to have the determinism, we need one GPU per type. And this is a little bit like more complicated flow that shows the full picture. Side, it's 4 components. So we generate like a pair of keys that we will use for access. It's like a temporary token. And then we start the green thing on the right side. We start a job, which is, for example, llama-free executor, so that you can send queries to this llama-free instance, images, text, whatever you want, and get the answer from them, streaming it back. And then this validator can run requests on it in batches. It can run it one by one. It can just run one request and then close it, whatever. And before the transmission ends, the result of the job needs to be signed by the miner, because otherwise it won't be accepted. So the miner needs to take a responsibility. It needs to say, okay, for this input using this algorithm, I have provided this output. And nobody can force the miner to do that. They have to compute it by themselves. And this proof can be then, if there is a cheater, this proof can be shown to other validators and say, hey, he somehow got this answer using this algorithm and this input, while that we run it again and that was not true, he's lying. And then other validators can run it on their trusted hardware, realize whether the hint is false or the miner lied, and decide who to ban and to kind of maintain the integrity of the subnet. And that's it. So I haven't been reading the chat for a moment. Let me scroll through it. Okay, actually, maybe someone wants to come on stage and ask the question. Okay, Rapido says, what happens if compute horde has an outage? Well, pretty much nothing. So the miners still have to provide the commodity, and we can evaluate 3% of it, or so. Okay, in the first version, we don't have like a rich support for it, but the framework is designed in such a way that if compute horde, which provides free compute to the validators, is not available, then the SDK is hookable in such a way that you can provide a different GPU provider. So RunPod, Fast AI, AWS, whatever you want. So you can assume, okay, we are going to run it for free, and if compute hordes doesn't work, then we just pay for pay hourly for the hardware in some cloud provider to use that as a backup. But compute horde won't be offline for most of the time. Oh, subnet 11 says that they already Dockerized their miner scoring and just need to be run on any capable enough GPU. But we have to talk later about that, because if you have it Dockerized already, then we can integrate it with the SDK and it should be good. We have to decouple scoring from evaluation. So it cannot be that the Docker container will say, these should be getting a score of 5. It should be able to say, this is an image of the monkey, for example, right? And then, or it's an image of the monkey that is like 89% quality. And then their scoring algorithm actually, which turns it into weights, should be on the validator.
I actually had a question on top of that. So let's say, for example, like I want to use like a API key that I obviously don't want to expose to the general public. So I want to.
I can't hear what you're saying. There is a lot of noise. Can you put your microphone closer or something?
Sorry, is this better?
No, it's actually worse.
Oh, okay. 1 second. Let me just.
Maybe you can plug in your headphones or something.
Hey, Ref, I think I heard you say.
Yeah. Sorry. Is this better now?
Oh, now it is.
Okay, great. Yeah, no, sorry. I was just asking about the what you were saying about the Dockerization. So let's say in the example, I want to run the Docker image, but I also want to find something like an API key that I obviously don't want to expose to the public. Is there like some kind of encryption scheme or something that I can set up to allow whoever is running to have access to a secret at one time, but not necessarily expose it to the entire network?
Hold on, Ref. On that note, is it possible to run it on a secure enclave? Because it sounds like that might solve Easy's concern.
I don't think that's possible. To your question, DP, we can demand from the subnet 12 miner that in a specific hardware class, because subnet 12 allows the miners to provide hardwares of different classes. So we can demand from them that if they want to participate in a certain class, which we're going to call subnet 11 validators, they have to have the miner with an API key provided already. So everybody will have their own API key that they will have to acquire prior to exposing this miner in our subnet. So they will bring whatever is necessary to help do the compute work. And if it means they will have to get an API key, then that's the job.
Okay, that makes sense. Yeah. Cool.
Okay. Easy trades. How about you?
Hey, I think I heard you say that a validator can now have one GPU for all subnets instead of multiple GPUs. How it is now is any number of GPUs depending on what the subnet requires. But so if it goes to one subnet or one GPU for all subnets, is there a certain type of GPU you need?
Right. So in this particular case, some subnets need different type of hardware than others to provide the validation. So let's say that we have like two popular choices. One is 4090, which is a very cost-effective card for running smaller models. So a validator will need to have one of those. And there is another one, which is A100, it has 80 gigabytes of memory, and it can run big models, although slower. And the validator will need both of those in order to do cross-validation. Because if it asks compute hard to calculate something on 4090, it cannot perform the cross-validation on A100 because these are different graphics cards. They have different optimizations, different precision, and different rounding, and it will just give you a different answer. However, what we could do is try to convince everybody to start using A100. And then theoretically, if every subnet says, okay, we need A100 for validation, then a validator will only need one GPU. And it actually, this GPU doesn't even have to be full-time. It can enable it for a few minutes per hour on some platform that charges per second, and that should be enough. The first version, you have to have a GPU server running 24/7. But in the future, we can actually reduce it to a fraction of that. So run validation on all subnets with a fraction of a single GPU. That would be ideal one day. Currently, it costs tens of thousands of dollars to run a single validator on all subnets. So bigger validators somehow, like, they bite the bullet, but the smaller ones, they have to wait copy because just they don't generate enough revenue to be able to pay for all the servers. Okay, let me scroll through the chat. Rail Minach Metov. I hope I didn't butcher your name. So he says we cannot run deterministic jobs, and that it is much slower to run deterministic jobs. Not quite. We managed to run it fast enough. And make it deterministic, but deterministic per hardware type, not deterministic at all. If you want to run it fully deterministic so that it's a portable algorithm and gives you the same answer on different GPU types, this will be super slow. Like, I don't want to say 1,000 times slower, but something like that. Tens or hundreds of times slower. But if you restrict yourself to the same GPU type and same firmware version, it's okay. There is a little bit of an issue with streaming and batching. So on some of those GPUs, you can run multiple jobs at the same time, and it will be faster than running jobs consecutively. So start one, wait until it finishes, and start the other one. And this can give you a boost of like 10 times, 30 times.